everyone. Welcome to our Tuesday and Wednesday lesson video. So sorry if we missed you, and welcome back if you're just rechecking what we went over. So we started our lesson with our warm-up. So I had you filling in that nucleide symbol. So we had the A, the Z, the X, and then the blank box. So that A is our mass number. So it says here that we have an atom with an atomic number of 34, a charge of -2, and a mass number of 78. So with that information, we put our mass number there in A. So I've got 78 is my mass number. Then Z is my atomic number. So I'm going to cover up the Z. My atomic number was given as 34. Also our number of protons, good. Then X. Now this is one you actually had to look up. So personally, I have, you'll never believe this, periodic tables all over my house. So if I look up number 34, it's over here on this side of the periodic table. Its initials, its symbol, is capital S, lowercase e, selenium. Chicken is actually a very good source of selenium. We need it in our diets. And then this unlabeled box up here is for my charge. So it mentions here it's a charge of -2. So in this box, you could either write 2 minus or -2. Either one is correct. I just think it looks neater to put the symbol behind the number. So that's just my preference. It is just as correct to put it -2 as well. Your homework tonight is to do the matter review quiz because tomorrow we have a unit test. Tomorrow in class, you will have a timed open note Unit 1 quiz. Unit 1 test, Unit 1 quiz. It is our summative assignment that goes to our Unit 1 notes. So our matter review quiz shows you what kind of questions I'm going to ask you on our unit test so you can prepare. Now, the first time you take it, you will see your incorrect answers along with the correct answers. So there's no reason why anyone should get less than 100% when I put in the grades for that homework. So then in class, I announced a last call for POGILs, an absolute deadline. I've written down when I made that call for each class because I'm grading the last time you submitted your POGIL before that time because we went over the answers. We then went over that pen homework chart, and then we went over and talked about the physical and chemical changes lab. We want to make sure we were on the same page there. So here's part of task 1 of the POGIL. The first thing it asked you to do was to go ahead and circle all of the protons, and then count, and then circle that same number in the symbol. So I have 8 protons here that I circled. So then I circled the number 8 on my nucleide symbol. So all of your nucleide symbols, that bottom number should be circled because that's the number of protons. Then it asks you to add your protons and your neutrons together, the total number. So I have 8 protons plus 10 neutrons gives me a total of 18. Then you're supposed to take this number and make a box around it in your symbol. So every symbol would have a box around the top number, your mass number. And then if it was in the name as well, so oxygen 18, I put a box around my mass number around 18. Once you got to the ions, there wasn't anything to box around in the name. So then, task 2 said to circle and compare the number of electrons in the oxygen 16 atom and the oxide ion. So I'm going to let the oxygen 18 stand in for the oxygen 16 here. But if I count my electrons, I have 8 electrons in my oxygen 18 or oxygen 16 atom. But when I count my electrons in my oxide ion, now I have 10 electrons. So to compare them, I have 8 versus 10. So what happens to the number of electrons? Let me move that so you can see it a bit better. What happens to my number of electrons when my atom becomes an ion? I've gained 2 electrons. I went from 8 electrons to 2 electrons. I gained 2. Then on the next page, you have those 3 images of 3 carbon isotopes. And then you're asked the following questions. how many protons are in each of the oxygens that you just worked with. So all of them had 8 protons. How many neutrons were found in each of those 3 oxygens? Well, we had 8, 10, and then 8 neutrons. And then you were asked how many electrons were in each of those 3 oxygens from task 1. And that was 8, 8, and 10. So one of the things we really like about POGILs is there's a central idea that it's trying to make sure you understand how everything revolves around some big central ideas. So we tend to ask you a lot of questions that all have the same answers. So what do all of my oxygens have in common? The number of protons. What do all of my hydrogens have in common? The number of protons. What do all of my carbons have in common? The number of protons. So what is it that determines the identity of an atom? It is your protons. Every single arsenic will have the same number of protons. As long as I look at something with 8 protons, I know that I'm looking at oxygen. Because if I have one more, I'm no longer looking at oxygen. If I have one less, I'm no longer looking at oxygen. It all depends on how many protons we have. So then the next set of questions, my left hand superscript, so at the top but behind the letter, is my mass number. So we put a box around A after we counted the number of protons and neutrons. So protons plus neutrons gives us our mass number. And that's why we put a box around it in task 1, task A. Hydrogen 1, 2, and 3 are isotopes of hydrogen. Oxygen 16 and oxygen 18 are isotopes of oxygen. So what's different between my isotopes is my number of neutrons. They have to have the same number of protons to be the same element. But when I change my neutrons, I now have an isotope. I have heavier atoms and I have lighter atoms because I have more or less neutrons between my different isotopes. And what has to be the same? Again, my number of protons. Now, if someone has a symbol in the upper right-hand corner, that's called my charge. It tells me I have a charge if there is anything written in that top right-hand corner. If there is no charge, I just write nothing. But any charge, I have to write my number and the magnitude, the number, and if it's positive or negative. So looking again at oxygen and oxide, what changed between those two? It was the electrons. I had 8 electrons in my neutral oxygen, 1 electron for every proton, 1 negative charge for every positive charge. But then in my oxide ion, I had more electrons. I had 2 more electrons than protons. I had 2 negative charges that were not being canceled out by my positive charges in my nucleus. So, are electrons lost or gained? They can be lost or they can be gained. So if I look at our examples, my oxide ion gained 2 electrons. It went from 8 to 10. My chloride, it went from 17 electrons to 18 electrons. But my beryllium, my neutral beryllium atom would have 4 electrons, but now my ion only has 2. So I can gain electrons or I can lose electrons. Some elements only ever lose, some elements only ever gained. You're going to start to see why that happens and what the patterns are soon. How is the magnitude? So the amount of the charge determined. So why is it a +2 for oxygen? Why isn't it not why is it a -2 for oxygen? Why isn't it a +2? Or a -1? So how is the magnitude or size of a charge on an ion determined? It's the number of electrons that have gained or lost. So oxygen gains 2 electrons for a -2 charge. Chlorine gains 1 electron for a -1 charge. Beryllium lost 2 electrons to get a +2 charge. So the number of electrons that you've gained or lost is your charge number. It's the amount of your charge. Then in our POGIL, we had this pen chart. Now, this pen chart is a lot more complex than what you're going to see on your test tomorrow or Friday. So your Unit 1 test is not going to have these last two columns. Your Unit 1 test is not going to deal with ions. So there will be no charges, there will be no ions, there will be no atoms or ions. They're all just atoms. So your protons will always equal your electrons on your test. That being said, I still went over the first two rows. So here I've got 12, 6, and carbon. There's no charge here. So my Z is the number on the bottom. So that's my 6, my atomic number. 12 up here is my mass. So my A is 12. If I know that my atomic number is 6, that tells me my protons are 6. If I have no charge written here, that means I have no charge and I'm an atom. If I have no charge, then that tells me my protons are equal to electrons. So if I have no charge, my protons being 6, my electrons will be 6. And then my mass number is 12. So if I take my 6 protons away from my mass number of 12, I'm left with 6 neutrons. The next one was a little bit more tricky. Here I was told that my atomic number was 15. My neutrons was 16. My charge was a -3, making this an ion. So I always like to start with the easiest things. My atomic number was 15, so my number of protons is 15. I have my number of protons being 15 and my neutrons being 16. So 15 plus 16 gives me my mass number of 31. Now the electrons are a little bit more tricky because I have a charge. Now, your charge is equal to your protons minus your electrons. So you can solve this with a little bit of algebra, just solving for your unknown. But here's how I like to think about it. So you can go either way that works for you is for you. I see that my charge is a 3. So that means I either have 3 more electrons than protons, so I have 18 electrons, or I have 3 less, so maybe I have 12 electrons. So I know my answer is either 12 or 18 because my charge is a 3. Well, my charge is negative. So think about homework. Okay, so if I'm feeling upset about my homework, if it's negative, that means I have more homework. So if I have more homework, I have more electrons. Electrons are like homework. So since it's a negative charge, that means I have 3 more electrons. So my total number of electrons is 18. So then you took this information to make your nucleide symbol. So 15 is my atomic number, it goes on the bottom. 31 is my mass number, it goes on the top. My -3 is my charge, so you can write -3 or 3 negative. Either one works. I just think it looks cooler. And then I need to take out a periodic table and look up element number 15. Element number 15 is phosphorus with a capital P. I did not take time in class to go over the rest of the answers on this table, since this is more difficult than what you will see on your quiz. But these answers have been posted to our past week's lesson, part of our Bitmoji classroom, so if you want to review your answers, you may. Then you were writing your isotopic notations or your nucleide symbols for the following 3 atoms and ions. Here I have 6 protons, so my atomic number is 6. I have 6 protons and 7 neutrons, so my mass number is 13. I have 6 electrons and 6 protons, so I have no charge. Then I just need to look up my symbol, so element number 6 is carbon with a capital C. Then here I have 40 protons, so my atomic number is 40. 40 protons plus 50 neutrons gives me a mass number of 90. 40 electrons and 40 protons tells me that I have no charge, so I write nothing there. And then I look up element number 40, and it's zirconium, so it's capital Z, lowercase r. Then I have 28 protons, so an atomic number of 28. 28 protons plus 33 neutrons gives me a mass number of 61. And then I had 26 electrons and 28 protons. So I have a difference of 2. So I'm going to have a charge of 2. But now I have to figure out, is it a +2 or a -2? Well, I have 36 versus 28, so I have less electrons than protons. So if I have less electrons, if I have less homework, that makes me happy. So less electrons means a positive charge. So +2 or 2 plus. Then the next 6 questions, we're asking you to make diagrams like in task 1 at the beginning. So you were given the nucleide symbol and now you were asked to make the atom. So you could do it 2 ways. You could draw a bunch of P's, N's, and E's like before in task 1, or you could do it the kind of cheating way like the question right above. Because all 3, A, B, and C are all nitrogen, they all have 7 protons. This nitrogen is nitrogen 14, so my 7 protons plus my neutrons needs to equal 14. So I have 7 protons, 7 neutrons. Then there's no charge listed here, so I also have 7 electrons to equal to my 7 protons. Again, 7 protons for nitrogen, but now my protons and neutrons need to equal 15. So instead of 7 neutrons, I have 8 neutrons. I have no charge, so I have 7 electrons and 7 protons. And then my last one that I showed you here, 7 protons to make it nitrogen. I need a mass number of 14, so 7 plus my already there 7 protons gives me 14. But then I have a -3 charge. So I either have 4 or 10 electrons. I either have 3 fewer electrons or 3 more electrons. Well, the charge I've been told is a negative. So negative, so that would be more homework. If this was homework, I'd be upset if I had more. So therefore, I must have more electrons. So I have 10 electrons total. Then the last question was asking what's the total charge on all atoms and why? The total charge on every single atom is 0 because an atom has no charge. My protons are equal to my electrons. Once I start fiddling with my number of electrons, I no longer have an atom. I have an ion. And atoms and ions function very differently. If you get solid sodium, atomic sodium, so no charge wet, it will explode when it gets wet. But a sodium ion is what makes up salt. And we do not want salt exploding when we put it in our mouth, if we put it on our fries and then eat it. So ionic sodium is very safe for us. So once I gain and lose those electrons, they function a lot more differently. Then I took the time to go over the answers and how we solve the answers and the pen homework. Here, number 1, I've got helium. I've been told that helium's atomic number is 2. Its mass number is 4. So if I know my atomic number is 2, then I know that my protons are 2. If my protons are 2, I know that my electrons are 2. Remember, there are no ions in this chart. On your quiz tomorrow, on your unit test, unit quiz, there will be no charges, no ions. So if you know your protons, you know your electrons. Then I was told my mass number is 4. So 4 minus my 2 protons gives me 2 neutrons. Then I have magnesium. Here I've been told magnesium has an atomic number of 12 and 12 neutrons. Well, if I know my atomic number is 12, I know that my protons are 12. If my protons are 12, I know that my electrons are 12. Then to find my mass, I just add my 12 protons to my 12 neutrons, and I got 24. Now I'm going to skip to bromine. What I like about bromine is that they do not give us the atomic number or protons here. In bromine, they give me my mass and my electrons. So this might cause you a second to think about how to solve this, because we've always started with protons or atomic number. Well, if I have my electrons, My protons are equal to my electrons. So if I have 35 electrons, I have 35 protons. If I have 35 protons, then my atomic number is 35. Then I was told my mass number is 80. So 80 minus 35 protons gives me my 45 neutrons. The answers are now revealed whenever you go and check your work in our homework quiz, your pen chart homework quiz. They were released and started to show to you as of Saturday night. Then we started going over our physical and chemical changes lab. I just wanted to make sure that we were all on the same page about what was physical and what was chemical. Now, this lab was largely graded on completion. Your lab observations are what you observed, so I can't really say that you're right or wrong as to what you observed. I only took off points usually if you left things blank, or if you wrote down things that you could not observe, or if your observations were not very descriptive. So for instance, clearly my magnesium ribbon has mass. But if you just wrote down has mass, that doesn't actually describe anything about that magnesium ribbon. You also wouldn't be able to tell me how much mass there was since you weren't able to physically manipulate it. You had to do your best to give descriptions based on what I told you about the materials or what you could observe from the images and the videos we provided for you. There were a few that I didn't love, but you did the best that you can since it was a virtual lab. For instance, I saw for one of our samples, someone wrote down small. If we were in the laboratory, I would absolutely not accept that. Size and amount are physical properties, but you have to be more descriptive. So if we were in classrooms, if we were in the laboratory performing the lab like this, you would be able to say that the magnesium strip was 3 centimeters long, or that the liquid, there was 50 milliliters of it. So the amount and size are good physical properties, but you really couldn't comment on it here. Now, if you said small or large, I accepted it for this time around, but I just wanted to clear that up. All right, so demo 1, this is one that we were able to talk about in all of our classes. This was a chemical change. We saw that there was light and heat given off by this reaction, and that we had a new substance after the fact, so this was a chemical change. Here, demo 2, I talked about this a bit more in the posted video lesson, but here what happened is the copper sulfate pentahydrate is kind of like a mixture. There's 5 waters stuck to every one copper sulfate, but once we put it into the fire, we boiled off or evaporated that water. So even though those waters were kind of stuck, they weren't bonded. This was a mixture of copper sulfate and water. It was so very little water mixed in there eventually at the beginning that it didn't really look like a solution, doesn't really look like a mixture, it just looks like crystals. But it was impure, it was a mixture. So once we put it over the Bunsen burner flame, it started to turn white. That water evaporated out. My mixture was separated. Then, after it was cooled, some water was put back in and it turned back to blue. Now, a color change normally means that a chemical change has occurred. However, this is an exception. This was a physical change. Boiling or evaporating water is just taking it from one state of matter to another. That is a physical change. The chemical composition is not changed. Also, we had a mixture of copper sulfate and water. We separated that mixture. Anytime you separate a mixture, it's physical. And then at the end, we just remixed the water back in. It didn't create a new compound. It was just redoing that mixture. So demo 2 was a physical change. Investigation A, some more properties, things that I noticed. For quite a few of the solutions, students described it as being water-like. Water is a very strange, very unique chemical. It seems very ordinary to us because we interact with it every day, but its properties are very strange compared to most things that we interact with that are not water. So describing something as water-like is not a very good descriptor. Another thing is that clear does not mean colorless. Colorless is different from being transparent or clear or see-through. So for instance, this is a blue transparent liquid. I can see through it, but it does have the color blue. Now, I did give the mention, if you listen carefully at the end of class, that this beaker does get warm when you do this experiment. And you can also notice you go from a blue solution and silver metal to a red metal. If you watch this long enough, you actually start to watch the solution turn a bit of a grayish color, which is really neat. It's hard to see the gray. But this is a chemical change. That red stuff that precipitated out of solution is a new chemical compound. What's actually happening is the aluminum and the copper are swapping places. So I'm getting solid copper metal, and my aluminum is becoming aluminum chloride. And another thing that quite a few students point out is you can see bubbles as the reaction takes place. That's showing that a gas is being created. So I've got a new substance, I've got warmth, I've got bubbles, I've got gas. These are all indications that a chemical change has occurred. Investigation B. A lot of students said that when you add salt to water, it does not dissolve. The original lab had students also stirring, and I think leaving that one word out caused some confusion. Salt does dissolve in water. If you pour enough salt in water, and I think that's in the case of what happened in the video, then you will get a mound of salt at the bottom of your beaker or your cup. But you can only dissolve so much of it. But salt does dissolve into water. And then when you put it on a hot plate and completely boil or evaporate out all the water, that is a physical change. So boiling and evaporating are changes of state. You go from liquid water to gas. You're still water. So that's a physical change. You're also separating a mixture. When you dissolve salt into water, you're making a salt-water mixture. So if I boil off all the water, the salt is left behind, and the water is now a gas, and it's been separated out. So I have separated a mixture. This is a physical change. My salt is still salt. My water is still water. Now, there seemed to be some confusion with investigation C, especially when it came to the potassium iodide. I had quite a few students telling me that potassium iodide was a yellow powder, was a yellow substance, was a yellow dye. Potassium iodide and my lead nitrate are both in this photo. They're both clear and colorless solutions. If you said it was a yellow powder, I understand how you got confused, and I didn't take off any points. I did correct you though, and I want to make sure that everyone understands what's happening here now. So I have two clear solutions, my potassium iodide and my lead nitrate. And when the two clear liquids are mixed, that's when I see those yellow solid particles just appear in the beaker. So I've got a clear solution. My clear solution is being poured into my other clear solution. And where those two solutions meet, I have this yellow solid. Now, it's kind of hard to tell that it's a solid from these images. When you do this in the lab, it's also hard to tell that it's a solid because it kind of fills up the beaker in such a way it looks like a yellow solution. But if you look really carefully, like at the individual pixels, it doesn't actually look like two different colored liquids mixing. If you've ever dropped some food dye into some water, it makes these beautiful circular curls. It makes lots and lots of curls and loop-de-loos. This is kind of exploding out like a bit of a cloud, but you don't get quite those loop-de-loos. This is a very minute detail, so I don't expect anyone to have noticed it. I wanted to point that out. It's just a neat thing, I think. I think in this one you might be able to see it a little bit better. That it's kind of chunky. It's little dots of solid stuff. I don't know why I resized it down. So this is a chemical change. There is a dramatic change in color from no color to bright yellow. And I had two liquid solutions, and now I have a liquid solution and a solid. So that is a chemical change. Investigation D, I don't think anyone got the first change wrong. Crushing chalk with a mortar and pestle is a physical change. Another thing I kind of yelled at students for, but I did not take off points, is a lot of people describe the flavor of vinegar or salt or water. You should never use taste as a descriptor. Unless I say you can use taste as a descriptor, you should never use taste as a descriptor because we do not taste things in the laboratory. Now, since we were not actually in the laboratory, I'm not too concerned that any students went and tried to find their own substances to taste, but you never eat or drink in the lab, so tasting something would imply that you tasted it in the lab, so that should not be a physical property that you list. Again, if that was your only mistake, I did not take off points for that, just, told you why you were wrong. And then lastly, that is a chemical change when you mix the vinegar with the chalk. You get bubbles, you get a gas that is forming. So that is a chemical change. So that's everything we went over today in our class. Don't forget interims go out on Friday. There are a lot of missing work still out. Now, a lot of deadlines have passed. For instance, today was the deadline for the lab. Whether I saw you on Tuesday or Wednesday, the day I saw you was our official deadline. After the deadline, I do not have to give you a grade. You have earned a 0. However, I can be sometimes convinced to give partial credit if an assignment has been completely finished and is mostly correct and is earnestly done. I might be persuaded to give you some partial credit on a case-by-case basis. So get in anything that you were missing and study up for our test tomorrow. It's open note, but it is time, so you don't have the time to look up every single question. You have those notes as a reference, but you really want to use them as little as possible. All right, well, I hope everyone stays safe and makes good choices, so I see you guys on Thursday or Friday.